Okay, let's start. So, can you all see this? Can you all see this? Hello, hello.
We
Well,
can see the slide. We can
Yes,
see the
sir.
slide.
okay. So in the last class we did one numerical. This was the numerical that we did now. Yes or no? This was the numerical that we did. So here it will be in the solution. It was given as cos theta. So you have to write it as sin theta. Okay. And the values are same, but it will be just sin theta, not cos theta. That means sin. It will be sin 60. It will be sin 60. Okay, is it clear? In the answer it was written mistakenly by them as cos, but this is the one that we have to follow. Okay, is it okay, students?
Got it, sir.
What about others? People are not just simply joining, no? No one is attending the classes. Sometimes I think you should attend it. It is good for you. Okay, let us start. So now we will start equilibrium of forces. So what is equilibrium? Equilibrium. Can you see this PDF? Hey Mazat, can you see it?
Yes, sir.
Okay, so let us start forces in equilibrium. So what is equilibrium? Equilibrium is defined as the condition of the body which is subjected to a force system whose resultant force is equal to zero. That means what? Suppose this one, suppose this one. Yeah, please mute your mic. Wakila Songki, please mute your mic.
No, sir.
Please mute your mic. Noise is coming. So these are the two forces that are acting, okay, from this point. That means what? If this is said to be in equilibrium, then the resultant of these two forces are what? Zero. Then only we say that this is in equilibrium. Okay. So in this way we define forces in equilibrium. So equations of equilibrium for concurrent and coplanar force system. So this is the resultant of a concurrent and coplanar force system. That means what? These three forces, where they are starting from a same point and they are on the same plane. This is the point of concurrence. This point, okay, the central point O here. So this is the point of concurrence. So here, when the resultant force is zero, that means what? The all in all this whole system, the resultant is what? Zero. That is why the body on which this force system, this is in what? Equilibrium. Now let us define it in a different way. Okay, so how will you know that something is in equilibrium? Right. In order to know that some forces are in equilibrium, what we have to do is the sum of the x components of the forces. That means what? This one is F1, F2, and F3. If you resolve this into x-axis, and you find out the sum. So how will you resolve it? Suppose this is making an angle theta. So if F1 in x-axis, then what it will be? It will be this one. Yes or no? So similarly, here if this is another angle, so this is F2. So here look, F2 is in this direction. That means the resultant will be in this direction. So we are taking this as positive. That means what? This side, if it comes, it will be what? It will be minus F2 minus F2 cos. Suppose the angle is beta. Cos beta. Suppose this is angle beta. Then it will be minus F2 cos beta. Now similarly F3. S3 is making certain angle here. If this is suppose delta, then what it will be? It will be minus F3 F3 cos delta. So in this way what will happen? If you combine these two, that means adding means what? Here it will be F1 cos theta minus F2 cos beta minus what? F3 cos delta. So this 3 you have to add here for the x, for the x component. So here x components is here. Now similarly if you take the sine component, you will be getting what? Here it will be sine, no? So that means what? This one is sine, this one is cos. So if this whole sum, that means what? If the sum of the x components of the forces is equal to 0 and the sum of the y components of the forces of the system is equal to 0, then the equations, then the equations are in what? Then the equations are in equilibrium. Got it? What I am saying? Clear, everyone? So this is how we define the equilibrium thing. Okay. Now this is that explanation. Suppose f of x is 0, f of y is 0. Then in similar manner, another set of independent equations. That means what? If the moment, if the moment ma you can write in this manner. That means moment about a, comma, m, b. So these two moments are equal to what? These two moments are equal to 0. Then also you can say that this is in equilibrium. Okay, got it? So now what happened? We will just do one numerical. So here, how to the solution, that is the process of finding out the solution. Okay? So how will you find out the solutions? So how will you find out the solutions? This is depending upon this. Hmm. So now look at here. If you see P and Q, these are the two forces acting parallel to bar AB. Got it? These two forces are acting parallel to bar AB. Hmm. And is supported by this support in the middle, so that the bar is horizontal. So if the length of the bar is I, find the position of support O. You have to find out the position of support O from both sides. Now, how will you find out that? This is the question. Now, in order to find out this thing, what you need to do is, first of all, you have to draw a free body diagram. Okay? We have to draw a free body diagram. So how will you draw that free body diagram? Can anyone say what is a free body diagram? Can anyone say
A
what is
body
a
which a diagram which shows the complete diagram of the only force.
all the forces that are acting? Good. So that means what? In free body diagram, you have to see how all the forces are acting on the body. So here you have to draw a free body diagram, okay, of the member force. This one and this one. Then we have to find out the number of independent equations of equilibrium of the force. Considering this summation of f of x equal to 0 and summation of f of y equal to 0. So once you find out this f of x equal to 0 and f of y equal to 0, after that you have to find out the moment about different moment about A and moment about B. So these two things should be equal to what? These two things should be equal to 0. Then only you can compare the number of unknowns with the independent equation. And then we have to solve it and then get the results. This is basically the steps. How will you? These are the four steps. So how will you get the results? The things that you are doing, we have been doing this sum, na? We have been doing those numericals. So that thing only you will have to do. Okay? Is it clear, everyone? Is it clear, everyone?
Uh,
Yes. Okay. So let's go to the next lecture now. This is what? This is friction. So now friction. What does friction mean? you know what is friction? Does anyone of you have any
Yes,
idea?
sir.
What is friction?
When we slide or
Hmm.
when we
That's it.
slide above the body of the another body, then we will get an opposite force
Hmm.
from the body that we are sliding on.
Then
That
what will happen?
opposite force is called that opposite force is known as friction, from my opinion, sir.
What about others? Yeah, can anyone else say? What about what is friction? You know what do you mean by friction? Yeah, does anyone know?
The action of one surface rubbing against another.
Hmm. Then what happens, Nishita? Then what happens? Suppose a force surface is sliding over another. Then what will happen? No idea? No idea? Anyone? Nishita?
Uh, it will experience the opposite force, that opposite force is known as the friction.
Uh, uh, Nishita is Temazar is correct? Yeah, someone is saying, I'm not able to hear your voice. Can you please write in the chat if you have problem? Someone is saying in the definition again. If you have problem, then write in the chat. When you say
Force.
force, yeah, Mechuba. Good.
Okay, sir.
You are Mechuba? Yeah.
Yes.
My voice is not clear. Is my voice not clear? Yeah, is my voice not clear?
Maju, maju.
My voice is lagging. What about others? Temazar and all? Is my voice lagging?
It's okay, sir. Little
Okay.
bit for me also, it's okay, but for other, I don't know.
Oh, okay.
Sir, I wrote on the chat box.
Yeah, I got it. Jambe, right? Good, good, good. So, is my voice lagging? Is there any lag in the network?
No, for others, it's
Hmm,
okay.
it's
I
okay.
don't hear anything.
If anyone face problem, tell me in the chat, okay? Hmm. So, let us go to friction now. What does friction means? Suppose, suppose you are placing one body over another. So, if you are placing one body over another, then what happens? If you are placing one body over another, then what happens? It will eventually slide, right? Suppose one body is sliding over one another. Now what happens? After some time, the body comes to a stop, right? Now that body, if the body comes to a stop after some time, then what will happen? Then what will happen? Then it will definitely what? It will definitely stop the movement, right? So this is known as what? This is known as friction. Now I'll show you one slide. You can understand it much better. Are you able to see one slide, students?
No, sir.
No, no. Wait a minute. Huh? Now, now are you able to see?
We can see.
Yes, sir.
If you can see, if you look at here, if you look at here, then what happens? Look, this is what. Can you imagine this part? What is this? What is this thing? What is this?
It is a body.
No, no. What? Why? Which is this? This is the thing that you see every day. This is a very practical thing. Any idea what is this? I'm asking everyone. What's this part? Whole thing.
Rubber. Rubber.
No, rubber is I know. Anything else? Lekha? Lekha Tama. Anything else? Can you say? This is a
Brake
very
shoe.
good example of friction. I'm telling you, it's very
It's sir, brake shoe, brake shoe.
yeah, very good. This is the brake shoe of a what? Cycle. This is a cycle tire, na? Yes or no? This is the whole
Sir.
frame. You apply the brake here.
Yes, sir.
Everyone can see it. This is a brake shoe, na? Now, can you recall? Yes or no? Yes or no, everyone?
Yes, sir.
Hmm. Good. So this means what? If you apply brakes here, if this is applied here in this part, then eventually what? The cycle stop, right? That means what? You are applying certain resisting force. That means what? This rubber surface, this rubber surface is applying some resisting force on this one, and then which is making it stop, right? So this is known as what? What is this force? This is known as the friction. It's simple as that. So that means what? Suppose a resisting force is applied, then if the movement is stopped, then this is known as friction. Now there are certain examples of this where friction is involved. This one. If you look at the bottom two things, this one car, and this one. Look at the brakes of the rails. So here it is friction is involved. Then here between the railway track and the wheels there is friction. Now if this F1 car is driving, look, here it is friction, here it is friction. Yes or no? Now in all these machine parts everywhere, you will see what? You will see friction. Is it clear? Is it clear?
Yes, sir.
So you can see friction everywhere. So this is a basic example of friction. So now let us discuss the types of friction. Are you clear with the what is friction now? Are you clear? What
Yes,
is
sir. Clear.
good, good. So now let us discuss what are the different types of frictions. Hmm. Can you see this? Can you see this, everyone?
Yes, sir. Back to previous one. Friction.
Yeah, good. So now what is this? Look at the different types of friction. Number one is what? Number one is static. Then number two is kinetic. Then number three is rolling, and number four is what? Fluid. Now let us define everyone individually. Now what is static? Static friction, it comes into play when a body is forced to move along the surface, but the movement does not start. Now look, I'm giving you an example. Suppose you are trying, suppose you are trying to push a roller. Have you seen rollers, road rollers that they use? Have you seen rollers?
Sir.
So if you are trying to push a roller, what will happen? It will not move, na? Not move, na? That roller won't move, right? So that means what? You are trying to apply some force, but that thing is not moving along the surface. That means the movement does not start. So this means what? Some amount of friction is definitely acting on the roller, because of which the movement is not started. So this kind of movement is known as what? Static friction. And the static friction, you just remember, it is always equal to the external force, or it is less than. That is why once you are applying external force, it is not moving. So that is why it is equal or less than. And the direction is always opposite to the direction of motion. So this is what is now. You remember one thing always, friction, in friction what happens? The direction is always opposite. Opposite to the direction of motion. So here the magnitude of static friction, it depends upon mu s. That means coefficient of static friction, and n. N means what? Net normal reaction of the body. So this magnitude depends upon these two factors. Is it okay?
Sir.
Yeah, okay. So now after going this one, we just go to the next one. That means in static friction, static means what? The body remains static. That means there is no movement, right? So if there is no movement, then the body is static. So this is known as what? Static friction. Now we go
Sir,
to
what
what?
is coefficient of static friction?
What?
Coefficient
Coefficient.
of static friction, sir. What is that?
Coefficient of static
Yes, sir.
friction. Yeah, that is what? It is a coefficient. That means if you get the formula, once we derive the formula in below. So once we derive the formula, you will be knowing that this is the ratio. So if this is the ratio is present, then what happens? We have to apply a coefficient. That means what? Suppose I'm giving an example. Wait. Suppose this is a body. Now if this is a body, now if this is, that means wait, that means this side here it is. Look, give me a minute. Suppose this is a body, okay? Now here the force that is coming here, it is the normal reaction that the body gives, okay? Now if you are applying force from this side, then this is what? F equal to mg, right? We all know this. F equal to mg. F equal to mg means what? This is the force This is the force that is applied by you. Suppose you are pulling it, so you are applying this force F equal to mg. Now this surface will give some resisting here because it is resting. This one is resting on a different surface. Suppose this will give a resting one. So that means an opposing force will be given. So this is given in the form of mu mg. Now mu is what? Here this is mu is the what? Coefficient of static friction. That means this is a coefficient for finding out the friction. Now this coefficient of friction is calculated by I mean this is known as what? The coefficient of static friction. Is it clear? If not clear, tell me. I'll explain it again.
No, sir, not clear.
In sir practical way, sir. मतलब it is in formula way, sir. मतलब how why we should put coefficient and what is it
Ah,
mean in practical way?
okay, you need that thing now. How you now look then. Okay, then I'll explain it to you in that manner. Now in this diagram, if you see, let me take some different example. Suppose this is a body. Now what happens is here. So here, if you all know, here is one force due to gravity. Now here it is what the normal reaction is applied. That means the force that is given by the body. Now if you are giving a force F here. Now this is what F required. Okay. F required. This F required. This F required means what? The force that is required. Okay. Now if you see here, in this opposite side, that means you are applying a force in this side, na? So in this opposite side, a friction will apply, na? Yes or no? Yes or no?
Okay.
Got it? Now, if you have to find out coefficient of static friction, that means mu s. This mu s is given by F required. That means this one. That means this one. This one. So mu s is given by what? F required divided by mg. So this is the expression for mu s. Okay. Clear? So this mu, look, if you want something practically, I'm telling you one thing. Now, if you are applying a force here in this side, now you are applying a force this side, that means what? A body is being pulled in this side. Now, when you apply a force, definitely the body in maximum cases what happens? In maximum cases it comes, but in case of static friction, the body does not move. So if the body does not move, that means what? There is an opposing force that is being given here. Yes or no? Now you don't know the amount of opposing force that is being given here. You know you are applying mg force here or ma. I mean, you know You know you are applying you are applying some force F equal to ma. Now but you don't know how much opposing force is applying, right? In that thing only the coefficient of friction comes. Now you have to, this mu s is something that you have to multiply, so that you get what, you get the amount of frictional force. Now if you multiply these two, then only you will be getting what, then only you will be getting this frictional force. So this is just simply a coefficient, or simply an unknown value that you have to multiply in order to find out the amount of frictional force that is being active. Now it is clear. Now it is clear. Yeah, I'm asking. Now
We'll get little bit get idea.
okay, you got idea. Remote
We
Asi,
will
you just do one thing.
Yes
You have,
sir, yes sir.
हाँ अभी समझ में आया? हेलो,
हाँ सर समझ में आया सर.
अच्छा ठीक है. तो टेमदर
हाँ
एक बार
सर
पढ़ के
समझ में
देखो.
आया.
हाँ टेमदर, you just recall the notes, see the video. If you don't get any idea, next class you ask me. You have to just recall this thing. This is not difficult. Got it? Yeah, Meichuba, tell me. Meichuba, any doubt? He's raised his hand.
By,
It's
no, no,
fine.
by mistake. By mistake, sir.
Oh, by mistake, no problem.
Yeah, yeah, it's clear, sir.
Okay. So now after that we get what? Kinetic friction. Now kinetic friction and static friction, there is only one difference. The kinetic friction comes into play when the body just starts to move. Suppose here in the last thing we got we just discussed regarding what? We just discussed regarding when the body does not move, right? But in kinetic friction, what happens? The body starts to move. Then also an opposing force will be applied, na? That opposing force is determined by kinetic friction. Got it? The difference between kinetic and static friction. Is it clear? Is it clear?
Yeah.
Then rolling friction. Rolling friction is a force. Suppose a body is rolling. That means what? A body is moving or rolling. So now that motion, suppose I'm giving an example of a football. Now when you put a football, what happens? It just rolls down the surface when you kick a football. Now eventually it comes to a stop. That friction that comes to stop, that makes the body to stop, that is known as what? Rolling friction. Okay. Then fluid friction. What is fluid friction? Fluid friction means, you got it? What is rolling friction? Did you get what is rolling friction? Did you get what is rolling friction, students?
sir, when body is
Say me. Yeah, just say me.
Sir.
Say. Can you say?
Sir, frictional force acts on a rolling body.
Yeah, so what is an example of it?
roller.
Not exactly. I'm giving an example. Wait. Can you see my screen?
No, sir.
No, wait. Just give me a minute. Now, can you see?
Yes, sir.
Yes, sir.
Okay, look at this. Look at this body. Now, this is a ball kind of thing, no? So, it is moving. Then, eventually, what happens? Here, some friction is applied, so which will stop the movement of the body. So this is known as rolling motion, and the friction and force that is applied here is known as rolling friction. Is it clear now? Is it clear now?
Yes, sir. It is clear for me.
Okay. Yeah, Kabam Maro, yes sir. Okay, good. Thank you. So now fluid friction. At last we come to the fluid friction. When a body moves in fluid or in air, suppose look what is happening when you are just throwing a ball. Suppose you are throwing a ball, then that ball that ball comes to a what? Standstill. Now you are playing cricket. Now while playing cricket, what happens? You are playing the ball. We are always throwing the ball or bowling or something like that, no? So now, if you are bowling or throwing the ball, then eventually, what will happen? The ball will come to a stop somewhere, no? So this is basically known as what? Rolling friction. Okay, is it clear?
Yes,
This
sir.
is known as rolling friction. Okay. So any doubt for today's class? Any doubt
Not
for
none.
whatever others? No
No,
doubt.
sir.
Yeah, you can just give your attendance in the chat box. I guess everyone is clear today what is being taught.
Sir, can we leave now?